In this video, we're going to do a demonstration of using DeltaV to control pressure in a vessel. So right over here, I'll just quickly take you over to our DeltaV Professional Plus workstation. We have DeltaV Operate running currently. This here shows our process. We have air coming into a vessel, a pressure transmitter measuring the pressure within the vessel, the controller here, this is within DeltaV, calculating controller output and sending it to a valve that is venting the air off, trying to control pressure. Currently the control loop is in manual. You can see here I have the controller faceplate open. Just click, closes it. To open that controller faceplate, we click on the controller here in DeltaV Operate. Still in manual, and here we have a trend. This trend is showing the percent open of the valve, and the blue here is our pressure in the vessel. You can see on this, on the y-axis here we have 0 to 5 psi, and then on the x-axis down here we have 1 minute of time, and each one of these increments is 10 seconds. 1, 2, 3, 4, 5, 6 for 60 seconds. Okay, so just to demonstrate our process here, we're going to bump our valve open 10%. So I'll click here, change this to 45%, and we'll watch our process respond. You can see here our valve opened 10% and the pressure in the vessel started to drop off. So this here shows a self-regulating process, and it has a fairly quick time constant, probably about a second or two time constant. So about 2 seconds for it to get to 63% of its total change. Okay, so let's change this back to 35, the output of our controller. So our valve goes back to 35% open, and you can see our pressure builds back up to about 1 psi. So we're going to be assuming that our control loop normally operates around 1 psi. So when we do perform our tune on this, we're going to be performing a Ziegler-Nichols closed loop tune. We are going to be tuning it around 1 psi. So let's go have a look at the process over here and find this pressure transmitter PT100, our valve, and our vessel. So I'll walk you guys over. You can see right here is our vessel. This blue line right here is our sensing line. It runs down to our pressure transmitter. We're using a differential pressure transmitter. It has a maximum range of about 6 or 7 psi, so the 0 to 5 psi range works great for this transmitter. We use the heart field valve parameter within DeltaV to write our range values to the transmitter, the 0 to 5 psi range values, and it is connected back to the DeltaV control system through these twisted pair wires. You can kind of see there's kind of wiring and running everywhere here, but right here, this is our cable going to our analog input on card 1, channel 1, and we have a fuse hooked in series here with our analog input from our transmitter. So this is power sourced out. It goes through the fuse and then runs out to our transmitter and comes back in on this black wire here. This green banana jack plug is for shield, to help drain any interference that could come into play on our analog input loop. Okay, for our valve, so our valve here, this is our valve that's venting the air out of our vessel. You can see we have this 1/2-inch flex hose that's ran back to our vessel and connected right here, down here, and at the top of our vessel, this is where our air supply is coming in. So we have air off of our bench regulated to 5 psi coming into our vessel. Alright, so right now we have our valve open about 35%, just like we'd set up here in our DeltaV control system, 35% output. Okay, so what we're going to do first is we're going to place our control loop into automatic. I've already biased the controller at 35%. So just to show you how you bias it, so biasing is the value that the controller is going to output when we have 0 error. That means there's no error between our process variable right here and our set point right here. So our process variable and our set point both are the same value. In this case we want them to be about 1 psi. The biasing is the percentage that's going to be sent to our valve. So in this case, 35%. Because we know that when we have the valve open, 35%, we have 1 psi pressure in the vessel. So this should be already at 35%. Let's verify. So we'll go into our controller settings here and go down. Yes, our biasing is set at 35%. Right now our gain is a value of 1. So what I'm going to go and do is put this control loop into automatic. Because with the closed loop tune, we want to have the control loop in automatic. We bump it, then adjust the proportional gain, and try to get our control loop into sustained oscillation. So right now, we're in automatic. I'm going to bump our loop by changing the set point. I'm going to bump it up to 2 psi. So we'll see if our control loop goes into oscillation. So this trend is going to help us determine that. You can already tell that the oscillations got smaller and smaller and the control loop did not go into sustained oscillation. So that means we need to change our proportional gain. So keep in mind, our controller has to be set up for proportional only. This down here tells us that we're using a P action, proportional action on error, and D action on PV. You cannot select proportional only in DeltaV. You can only select this setting here to get rid of integral. The D action is not going to be used. We have it turned off. We have the rate setting set to 0. And setting the reset setting to 0, I've had trouble with. It still seems to use reset for some reason when we have our structure set up using the integral setting. So let's bump our gain. Let's try a value of 2. Okay, so I'm going to move I'm going to bump our set point back down to 1 psi. You can see our control loop is oscillating more this time. So it appears that we are in sustained oscillation. So that means that our ultimate gain for this control loop is going to be a value of 2. And if we look close here, we have about 1 complete oscillation happening every 5 seconds. So from here to here, that's about 5 seconds of time. So our ultimate gain is 2, and our period of oscillation is about 5 seconds. So looking here on the board, I've recorded those two values already, an ultimate gain of 2 and an ultimate period of 5 seconds. So using the Ziegler-Nichols formulas to calculate our gain value, our proportional gain value, and our period of our reset time, we enter our ultimate gain, multiply it by 0.5. So 2 times 0.45 gives us a value of 0.9. And for our reset value, we take our period of oscillation and divide it by 1.2. So 5 seconds divided by 1.2 gives us a value of 4 seconds per repeat. So these two values, we can go ahead and enter them into our DeltaV controller, and we will need to change our controller to have a reset setting, and then we can see how our controller responds. It should be close to quarter amplitude decay. That's the goal of the Ziegler-Nichols tune. So to do that, we click down here again on our detail button for our controller, and you can see our tuning parameters down here. Our gain, we're going to change to 0.9, and our reset, we're going to change to a value of 4. And to change our structure down here, we actually have to go into Control Studio. So open Control Studio, double click on our PID block, and our parameters should now appear, and we're going to be looking for that structure parameter. So press S. There it is right there. I'll double click on the parameter, and we want to change it to a PI action on error and D action on PV. So what this will do now, the proportional and integral settings will be used in this controller. Before we were just using P action on error, so there was no integral being used. That's how we were getting our controller into a proportional only controller that's required for the Ziegler-Nichols tune. So select this, click OK, and we'll do a quick download on our control loop. It's asking for an upload and a download, so we'll grab all the settings that we had written to DeltaV and DeltaV Operate, upload those settings, close, yes we want to save, and let's do our download. So we've downloaded these changes. We can go back into DeltaV Operate, and now you can see down here our structure has been changed to PI action on error and D action on PV. And we've got our values from our Ziegler-Nichols tune already entered, 0.9 and 4. So we'll close this detail window, and now let's try bumping our control loop. Let's go up to 2 psi, click OK, and let's watch our response. So you can see it somewhat has a slight overshoot, not quite quarter amplitude decay. We might need to increase our gain a little bit if we wanted to have a quarter amplitude decay, but it tuned the loop quite well. We'll just drop back down to 1 psi where we would normally control. You can see we have no offset because we're using the integral setting, so our process variable right here, 2, matches our set point of 2. Let's double click and change our set point back to 1, and watch how our control loop responds. So pretty close to quarter amplitude decay, not quite, but you can see here we're getting really close to 1 psi again. So there, a completed Ziegler-Nichols closed loop tune using DeltaV on a pressure control loop.